Hi guys, in this video I wanted to cover some questions and modifications that I did to my amplifier. And basically you can see on top first modification, it's a volume unit meter built around two LM324s as comparators to represent voltage across load, which is 8 ohm speaker system, to represent it as a bar display. And I wanna now cover some modifications inside and talk about why I am not going to do some modifications further. Basically, here you can see another modification. It's a protection circuit. It does two things: protects the speaker system from a large DC offset, which is gonna kill the speaker. It helps you in case when one transistor gets blowed, shorted, at pretty rail voltage goes directly through the speaker to ground. In my case, rail voltage is 25 volts. It's more than enough to fry that innocent 8 ohm speaker. And the second thing it does provide delay when turning on, so you can hear thumps and bumps and so on. And another questions about here, you probably can see little capacitor. It's a collector base bypass, or I don't know if it's correctly named. Driver is BD139, and little update that I wanna show. I replaced 2N3904 to N3906 with a BD139 and BD140 correspondingly, and to answer some questions. And why I got 4 diodes in a string, I happened to spend some time troubleshooting this amplifier, and when prototyping it I tweak the value so I get what I want. And with this circuit, which is kind of servo, which allows you to set desired quiescent current, when I get 2 diodes, it happens to not be enough. Suddenly current range that I can adjust it using potentiometer is not enough. 3 diodes, not enough. 4 diodes, that's bad. I can tweak it very nicely from a current that is puts output transistor into class B to almost class A. Now quiescent current, if memory says me right, is around 60 milliamps, which is just fine. And a little answer about offset. Increasing value of long tail pair resistor, which is over there, ain't gonna do much difference. It gonna do difference, but since in simulators transistors have almost identical or absolutely identical parameters, in real world they differ a lot. And to get low DC offset, you need to match the long tail pair very nicely. Their gain need to be almost exact. And I happen to match them so gain differs not more than in 10. So one is slightly more than the other, or slightly less. And the things I wanna cover about power supply. Power supply is roughly 100 watt transformer. It's slightly modified. Originally it has single winding, 24 volts AC. I dewound it slightly, made a center tap, here you can see it, and wound another 18 volt winding, so it gives me around 25 volts in each rail DC, smoothed up by these caps. Speaking of caps, I have now installed 2 caps in each rail, 4700 microfarads, 50 volts each. Pretty nice. This setup does pretty nice job in smoothing the hum from an AC. And a little modification too And I wanna say about thermal stabilization. I know you can put that transistor around. In my case it's 2N30 nanoform over there, near the potentiometer, near the trimmer point, to put on a heatsink, and it does provide negative temperature coefficient. The more temperature raises, the internal resistance decreases, voltage drop at the bases decreases, and current decreases, and things cool down. But I think it can do quite a job that I don't want it to do, because I think to perform correctly it does need that each heatsink will contain a pair of transistors, NPN and PNP. But in that case you need insulators, because collectors are having potential of your rails. And difference between potentials in my case is 50 volts. And what things I wanna say, you can see lack of insulators, so I basically did a T42 on this heatsink and T41 on that heatsink. So each amplifier basically have two heatsinks. One is for NPNs and one for PNPs. So I think thermal stabilization will give pretty inaccurate results, because one amplifier may go very hot, thus decreasing current of the other. Increasing current of the other will decrease, it will cool down, allowing another amplifier to heat up even more. That's my kind of simulation that I did in my mind. I don't know if it correctly, but I'm pretty sure it will do the job not very well, because one transistor from a cascade is here and another is there. So that's almost it. And offset, as I mentioned previous in the video, now is not a 60 millivolts, it's around 90 millivolts. And as you see, this clarifies, this does what it's done. This is doing what it's doing, because I said that gain of this transistor needs to be exact, and it's not. So it happens to be it. By the way, tone control section isn't really much interesting. TEL-084 contains each op amp is used. On the input you have a buffer, voltage follower, then you have a kind of back-signal tone control with a 3 potentiometers, bass, mid, treble, and on the output you have inverting amplifier. So basically I'll post a schematic I think in the end of the video, and because the video is going to be long, that's it I wanna say. See you next time, bye.